Good morning, students. Today we'll do new topic, ideal gas equation. Already you have done Boyle's law, Searle's law, Avogadro's law, the gas laws. When you combine all these gas laws, then you can put forward an equation which is called ideal gas equation. And this equation gives a relationship between pressure, temperature and volume. So what is ideal gas equation? The equation which gives the simultaneous effect of pressure and temperature, simultaneous effect of temperature and pressure on the volume of the gas, is called ideal gas equation, or it is also called equation of state. Ideal gas equation, or it is also called equation of state for ideal gas. Those gases which obeys this law, they are called ideal gases. Okay, now what about the equation? I'll derive the equation, derivation of the equation. You can derive the equation by combining all the gas laws like Boyle's law, Searle's law, Avogadro's law. When you combine these three laws, then you will get the ideal gas equation, and which is called also equation of state. You have got from Boyle's law P proportional 1 by P at constant temperature and number of moles. From Searle's law you have got P proportional T at constant pressure and number of moles, and from Avogadro's law you have got P proportional N. By combining these three laws, since all are related with volume is inversely proportional to pressure, volume is directly proportional to temperature, volume is directly proportional to number of moles. Since all are related with volume, so you can combine all these three laws, and when you combine these three laws, you can write P proportional Nt divided by P, because N and T directly proportional, pressure is inversely proportional. Ultimately, you can write P proportional Nt by P. When you remove the proportional sign, then a constant will come R Nt by P, or you can write Pv is equal nRT. This equation is called ideal gas equation. P means the pressure of the gas, V means the volume of the gas, N means number of moles, R is the gas constant, and T is the temperature. So this equation gives the simultaneous effect of temperature and pressure with the volume of the gas. Now what is R? R is a constant. This is one of the special constant. You have to learn the value of R also. R is a constant called universal gas constant. Universal gas constant, and it is also called molar gas constant. I will give you the value of R, and you have to learn the value of R, because mostly in chemistry equations the constant R is used, and that the value of R you should know, and you have to put in the numerical if you get R constant. So this PV equal nRT, this is called the ideal gas equation for n moles of gas, if where n is the number of moles. if you want to write the equation for 1 mole of gas, then the n value will be 1, I mean PV is equal 1 RT, I mean you can write PV is equal RT. Similarly, for 2 moles of gas, the equation becomes PV is equal twice RT. For 3 moles of gas, PV is equal thrice RT. So this equation is given for n moles. For n moles of gas, the ideal equation become PV is equal nRT. Now, this derivation of this ideal gas equation, it is very important. You can derive the equation by combining all the gas laws, Boyle's law, Charles' law, Avogadro's law. When you combine, then you can derive the ideal gas equation, and this equation followed by all gases, and the equation is PV equal nRT, where R is called the universal gas constant or molar gas constant. So many numerical you have to do by applying this ideal gas equation PV equal nRT. Now we'll study about this gas constant R, and the nature of the gas constant R. Nature of gas constant R. So you have got PV is equal nRT, or R is equal, you can write PV by NT. You know P means what? Pressure. V means volume. N means number of mole. T means temperature. You know what is pressure? Pressure means you can write force by area. Force by area gives the pressure. So instead of pressure, you can write force by area into volume divided by mole into temperature. This is equal, you can write force. Area means you can write L square, I mean length square. Volume means you can write L cube divided by number of mole into temperature. Here L square cancel, one L will left here. So ultimately you can write force into length divided by number of mole into temperature. So force into length means what? Force into length means you can write work done. Force into length means work, I mean force into distance gives work divided by number of mole into temperature. So like this way you can find out the nature of the gas constant. So ultimately what is gas constant? The gas constant R is the work done per degree per mole. Per degree means temperature. So the gas constant R is the work done per degree per mole, and this is the nature of the gas constant R. So this is important for exam. Derive the nature of the gas constant R. You will get the question like this, then you have to derive it like this way. Now we will find out the values of R. Values of R. Actually there are different values you will get for R depending on the unit. So I will give you the SI unit value, I will give you the CGS unit value. You have to learn all the values. So first time I will find out the value. As you know, at NTP, I mean normal temperature and pressure, at NTP condition, 1 mole of gas contain how much volume? It contain 22.4 liter. NTP means the STP. You can write STP also. So at STP, 1 mole of gas always contain 22.4 liters, which is called molar volume. Already you have got in first chapter. So you have got R is equal PV divided by NT. So if you consider number of mole as 1 mole of gas, temperature at STP, the temperature is always considered as 273 Kelvin. Pressure is considered as 1 atmosphere. Volume is 22.4 liter for 1 mole of gas. So when you multiply all these things, I mean when you do this calculation, then you will get 0.0821. The unit will be liter, then atmosphere, then per mole, then per Kelvin. So this is one of the value of R in CGS unit, because atmosphere is not the SI unit. In terms of CGS unit, this is one of the value of R.